Hi everyone, welcome to my YouTube channel. In this video, I am going to explain you how to calculate size of the nanoparticles with the help of X-ray diffraction pattern or XRD pattern. So we know that there is a formula to calculate size of the nanoparticle, that is we call Debye-Scherrer equation. So here you can see in this equation D is the diameter of the particle, nothing but size of the particle. So this was developed in the year in 1918 as the name of the Scherrer and Debye. So here to calculate size of the particle we require the capital K, that is we call shape factor. It usually lies between 0.6 to 2.08. Approximately we take it as a 0.9 or 0.89. Lambda is the wavelength of the X-ray of about 1.54 angstrom, and beta, what we want to calculate size here, beta is nothing but full width half maximum. So with the help of Origin software, once you plot the graph with the help of data, you can calculate. So theta is the angle of diffraction. Once you plot the graph, at what angle the beta value you are getting, you can substitute and calculate size of the particle. So here is the Origin software to plot the graph. Here I have the XRD data. So if you want to plot the graph, you should require the value of angle and intensity. Here is the angle and intensity values. So what I will do, I will select these two columns directly and copy the data, go to Origin, and here is the worksheet or the book. You can copy the data here, paste it, and you can just delete the unnecessary data here. We only want the angle and intensity. Okay. So here is the angle and intensity. So what I will do, I will plot, select these two columns, x-axis, y-axis, and plot the graph. So here is the required XRD pattern. So here we have the x-axis, that is angle, and along y-axis intensity. So what I will do, I will select the highest intensity peak. You can observe here. So I will just make the pattern visible more clear. So I can take the angle here about 20 to 100. Okay, you can see the clarity. Then here is the scale. You can select the highest intensity peak. This is the selector. Okay, still you can select and make it larger. Okay, so this is the peak which is having the highest intensity, and the angle is lying between 36 to 37, that is around approximately 36 point. You can also find out the angle here. Once you click on this peak, it is about 36.38. So in this formula you can use that theta value. So first let us find out the full width of maxima here. Then I will go to here analysis. Fitting. Okay, non-linear curve fit you have to select. Open dialog. Okay, once this interface if you get, then go to function here. Okay, in this section you should select Gauss. If you select Gauss, Then here the options will be active iteration. If you select, it will start doing the curve fitting, non-linear curve fitting. If you select this fit until converge, then it directly fit the curve after multiple iteration. If you click on OK, finally you will have the data for full width half maxima. Here I will show some options here. Residual formula. This is what the formula to fit the curve y equal to y naught plus a divided by using Gaussian. So if you go to sample curve, this is what the curve fitting. Here is the full width half maxima. These are the parameters we come across in this formula. Y naught, capital A. W is what the full width half maxima. So this is the curve, fitted curve, and here is the full width half maxima. Value of all the parameters in the formula has been given. So here you can go to the parameter section. You will get the parameters and their values. Y naught, XC, W and A. This W is nothing but the width. This is about you can see 0.17865 is the full width half maxima. Okay. Then if I say okay, then you can click on done. Okay. So here is the fitted data, and here are the required data for fitted curve. So here also you will get the values of the parameters. We require FWHM, that is full width half maximum 0.178. So you can refer this data. You can do the multiple iterations until it converges. Okay. So here is the graph. So here also you will have the value of the parameters. If you want to do the further curve fitting, you can again go to non-linear curve fitting, open dialog, and go to Gaussian, and click on the converge and OK.